Now that we've covered all the skills that we need to know for differentiation, we can now start applying it to more applications. One application is calculating the equations of tangents or normals. Now, in NCEA Level 2, you will have already learned how to calculate a tangent, but we will recap that and then look at finding what a normal is. We're going to start by just drawing a random curve and choosing any point, say there, calling that P. The tangent is the line that just intersects this point and goes at the same gradient as that point. So for example, it will look something like that. That is the tangent. The normal is a line that is 90 degrees or perpendicular to this tangent. So it crosses through the point that way. And these are at 90 degrees. Because the normal is perpendicular to the tangent, that means that we can apply a special rule which says that if two lines are perpendicular to each other or at 90 degrees, then the gradient of the first line times the gradient of the second line is equal to -1. Applying this to this question, that means that we have the gradient of the tangent times the gradient of the normal is equal to -1. We'll give an example for how this works and how we can see this in practice. So you may be asked to write the equation of the normal at x equals pi over 4 for y equals 3 cos 2x. Because this is a differentiation standard, of course we've got to differentiate first, and that will give us the equation of the gradient of the tangent. So dy dx equals 3 times, now cos differentiates to negative sign, 2x, and then chain rule, we've got to times by the derivative of what's inside the cos, or timesing by 2, giving us -6 sine 2x. Now we want to calculate what the gradient of the tangent would be at pi over 4. So when x equals pi over 4, the gradient of the tangent will be -6 sine 2 times pi over 4. That is equal to -6. Now that means that the gradient of the normal times the gradient of the tangent, which is -6, is equal to -1, and so the gradient of the normal is equal to 1/6. Basically, you can just learn that the gradient of the normal is equal to -1 over the gradient of the tangent, which essentially means change the sign. If it's positive, make it negative. If it's negative, make it positive, and then find the reciprocal of the fraction. So in this example, we're changing the sign of -6 to +6, and then finding its reciprocal, which becomes 1/6. Now, that is the gradient of the normal, but we need to write in an equation. The general equation that you should learn is y minus y1 equals mx minus x1, where we've got 3 important parts of this: y1, m, and x1. M is the gradient, and x1, y1 is a point. We already know that x1 will be pi over 4, because that's given to us, so we need to find y1. Well, to do that, we're just going to substitute pi over 4 into our original equation. So 3 cos 2 times pi over 4. That gives us 0. So now we have x1 is pi over 4, y1 is 0, and m is 1/6. Substituting into this equation, we then have y minus y1, which is 0, equals 1/6 x minus x1, which is pi over 4. And if we were to expand that, we get y equals x over 6 minus pi over 24, which is the equation of our normal. Question 2. You might get asked to find the coordinates of y equals ln 2x to the power 2, which are parallel to the line y equals 3x plus 4. Now, we need to know that parallel means same gradient, which means that the gradient of ln 2x squared should be the same as the gradient of 3x plus 4. So the gradient of 3x plus 4 is 3. Now, if you didn't know this, just differentiate that equation, you get 3. And that should be equal to the gradient of ln 2x squared. So we need to differentiate ln 2x squared. dy dx equals ln differentiates to 1 over the bracket and then times by the derivative of the bracket, which is 4x. So applying the chain rule gets us to 4x over 2x squared, or 2 over x. And so that means that 2 over x, which is our gradient function, must be equal to 3, i.e. x equals 2/3. Now the question did ask for the coordinates, which means we need the y value as well. So we will substitute our x value of 2/3 back into the original equation, y equals ln 2x squared. So y equals ln 2 times 2/3 squared, or ln of 2 times 4/9, which is ln 8/9. You don't have to put this into a calculator. You can leave this in exact form. If you wanted to round this, you must round to at least 3 significant figures. For me, I'm just going to leave it as 2/3 ln 8/9. Okay, I've got 2 more questions. Find the equations of the tangent and normal to the curve y equals 3 ln 2x squared minus 1 when x equals 1. There's a lot going on here. We need to find 2 different equations, both the tangent and normal, which means we just need to start by calculating the gradients. So dy dx equals to 3 times ln differentiates to 1 over 2x squared minus 1 times by the derivative of the bracket, which is timesing by 4x. This can simplify to make 12x all over 2x squared minus 1. Substituting x equals 1 gives us the gradient of the tangent, or 12 all over 2 minus 1, which is 12. The gradient of the normal will therefore be -1. Change the sign and find the reciprocal over 12. To find the equation, we also need the y value. So at x equals 1, y equals 3 ln 2 times 1 squared is just 2 minus 1, which gives us 0. Finally, we can now find the 2 equations of our tangents and normals. For the tangent, y minus y1, so y minus 0 equals m. The gradient of the tangent was 12, x minus 1. So y equals 12x minus 12. For our normal, the only thing that changes is the gradient. So we've still got y minus 0, but now it's negative 1 over 12, x minus 1. So your equation is y equals negative x over 12 plus 1 over 12. Final question, and this is a past exam question. We have a graph that looks like this. And we're told that that equation is y equals x squared plus e to the power of 2x. We're told that there's a tangent at x equals 1 to this curve, and when this tangent intersects the x-axis, we get the point P. We want to find P, which is the x-intercept of the tangent when x equals 1. So our sort of method here is to work out the equation of the tangent and then sub y equals 0. So we need to find the derivative, dy dx equals 2x plus, and e to the power of 2x differentiates to e to the power of 2x times by 2. So we get 2x plus 2 e to the power of 2x. Substituting x equals 1, the gradient of our tangent is 2 plus 2 e to the power of 2. And our y value, substitute x equals 1 into our original equation, we get 1 plus e to the power of 2. So our equation, y minus y1, which is 1 plus e to the power of 2, equals m, 2 plus 2 e to the power of 2, x minus x1, which is 1. And we want to make y equals 0 to find the x-intercept. So 0 minus 1 plus e to the power of 2 equals, and I notice on this right-hand side there's a common factor of 2. Take that out, 2, 1 plus e to the power of 2, x minus 1. We can get rid of the 0 to just get negative 1 plus e to the power of 2 equals 2, 1 plus e to the power of 2 times x minus 1. There's a common factor of 1 plus e squared on both sides, so they can divide away, leaving us with negative 1 equals 2, x minus 1. We want x, so divide by 2, we get negative 1 over 2 equals x minus 1, and add 1, we get x equals 1 over 2. So the answer for P is 1/2.